in the previous video, we have set it up our front-end project using vid. Then we have created our backend using a Spring slider, and then created a monorepo and pushed it to our GitHub. In this one, we will be building the backend of all things related to authentication. What you are seeing here actually is the front end that we will be building in the next video. In this one, we will be focusing on the backend, the logic that help all of this to work. For example, we can sign in a user. We can help a user to reset its password using its email. We'll also be sending emails. I'm gonna be showing you in a bit. We are also gonna be handling user registration. And just to show you what it would look like, let's say I want to create an account on LinkedIn. So I will be saying that my name is Yusuf, and I, let's say, work at, I'm not inspired, so I'm gonna say at apple.com, and my password is gonna be something like Yusuf. So when I hit sign in, I'm gonna get user not found because there is no user with this email. So let's create an account. So I'm gonna come here and paste my email, and then type my password, and then I'm gonna enter agree and join. So as you can see, an account has been created, and I have received an email. And to test actually everything related to email sending, we'll be using something that's called Mailhog. I'm gonna show you how to set up this in a bit. So we're gonna be using this. This actually emulates a SMTP server, which is a server that use everything that actually knows how to receive and send emails. So that's what we'll be using. And as you can see, I have received an email saying only one step to take full advantage of LinkedIn. Enter this code to verify your email. So far, my email is not verified. So if even I try to refresh the page or go to the home page, I'm gonna get redirected here because my email is not verified. So let's say I'm gonna hit this, and then I say validate. So now my email is validated, and I will come on the homepage of LinkedIn. And if you know, guys, that is how the homepage of LinkedIn look like. And we will be building this feed, the homepage, later in upcoming videos. For now, so that's the front end that we need for our authentication. And let's say I forget my password. So I'm gonna come here and say I forgot. So I'm gonna paste my email like this. I'm gonna say next. So I would receive an email here, as you can see, saying a password reset, and then I would grab this code and let's say paste it here. Let's say I give actually a wrong one, and I'm gonna choose a new password like this. So I'm gonna get an error saying that the password reset token has failed. Let me paste the correct one and let's type reset. So my password has been reset. So that is the front end, what you are seeing, and we'll be building in the next video. And in this one, we'll be focusing on the backend that's powering all of this. So to give you an idea of the backend, that's what we will be building. So we'll be having this project structure. We'll be having configuration controllers on the project level, like things that are going to be applied to all the LinkedIn backend. And also we'll be having a features folder where we will be having specific elements of the application. So for this video, we will be developing these two features. So the email feature and the authentication feature. So in the authentication, as you can see, we have our controller. So if I show you, that's where actually we're handling login, user registration, how to verify, how to validate emails, how to verify a token, how to also reset password. So everything you're seeing is done here, and we'd have some DTOs, a model which is going to be the user that's going to be stored in our database. So our database is going to be a MySQL database, and I'm going to also be showing you how to set up this database using Docker. So as you can see, we have a Docker compose file here, and that's what helps us actually to set up a MySQL database, and also the Mailhog, the SMTP server that I showed you earlier, that's helping us to test email sending and receiving. And to give you an idea of the front-end code base that we'll be building in the next video, not in this one. So this is the project structure of the front-end. So it's kind of similar to our backend. We'd be having components that are going to be used by all the features on LinkedIn, and we'd have a features called a features folder where we'll be having a specific feature. So we have the authentication feature, for example, and the feed feature. The feed is the homepage where we would have all the posts from our connections. So that is our project structures. So we would have the pages, we have the login page, we have the reset password, the sign up, the verify email, everything that I showed you in earlier. So in the page is going to be responsive as well. So let me actually just remove the token here, and if I refresh, I'm gonna get to the sign in page. So that's the sign in page. It's also responsive, as you can see. So I'm very glad I have worked very hard on this part of the project, so the authentication, and it's also going to be the hardest part of the project, because authentication is always the hardest thing to do. That's why we have a lot of software services that are selling authentication to people. So you will be learning a very, very valuable skill in this video and in the next one. So buckle up and let's get going. So that's what we have left off on the latest video of this series. We have just created a Spring project using Spring Initializer, which is this thing. So yeah, this thing. We have used this one to generate our backend folder that you're seeing here, and we also have used Vite to generate our React folder, which is this one. And I have changed one tiny thing about the backend folder, is that in the latest video we have chosen Maven as our build tool, and I have changed it to Gradle, and I'm going to explain why I have switched from Gradle to Maven. And if you are coming from the JavaScript world and you don't really know what these are, they are like let's say npm and yarn, so basically. And Gradle is the newest one, and it has features that are going to be handy for us, and I'm going to explain why I have switched. But for now, let me clone the project. So I'm gonna go here, go to my desk and run a git clone. So as you can see, it has created the folder here, and if I open it, we have the front end and the backend. So in the backend we have this build.gradle.kotlin. This is like package.json somehow. We have also this settings.gradle, and I'm going to explain what these are in a bit. So as you can see, it's very small. We have these things that are related to our build tool, and we have our src folder that contain the main. So the main is simply going to be one class for now, which is only this thing, and we also have one test folder. So let me open it using IntelliJ. So I'm gonna say open, and let me go to my desk. So open LinkedIn, backend, and open. You can use any text editor, but I will be using IntelliJ here, and we will not be using anything very specific to an IDE, so any IDE would work. So let me open the terminal, and actually that's this Gradle W and this Gradle.bat, they are like embedded Gradle script, so we don't have to install Gradle in order to work with the project. So we will used to be referencing Gradle, using Gradle like this, Gradle wrapper, and use it. And also guys, I will be assuming that you have some basic knowledge about Spring Boot in Java, and if you don't, you could watch like one video on YouTube. There are a lot of them, and come back. And if you have some basic knowledge, it's gonna be enough to follow this video and this series. So let me actually run the Gradle project. So it's gonna be Gradle boot run like this. This is actually gonna set up our project and make it run on localhost 8080, as you can see. Tomcat initialized with port 8080. And why we are talking about Tomcat here, because as you can know, a Java web application is actually firstly a Tomcat, which is a server. So we would run a Tomcat that's gonna receive all the upcoming requests, and that's gonna be calling our Java classes and then get back the answer and answer to the client. And if we were not, like if we weren't using Spring Boot, we would be setting up Tomcat ourselves, but Spring does it for us, which is handy. So let me open another terminal, and let's actually open the main. So as you can see, our main doesn't contain anything for now, just this thing. And if I visit the localhost 8080, we are gonna get this error because we don't have any we didn't add any controller that's gonna be responding on the on this URL. We'll do it in a bit. So first thing first, let me actually add the features folder where we will be adding all things related to a specific part of the application. So in this video we'll be working on the authentication. So let's add an authentication package like this. Authentication. Let me create a controller class, controller package, sorry, and then a controller class. Let me call it authentication controller, sorry. So, and don't ask, we're gonna be committing all of this at the end of the video. So this is going to be a REST controller. I'm importing it from Spring Framework.web.bind.annotation, and then we'd be having one. Let's say for now, we'll be having this. So we're gonna say okay, we're gonna be having a hello world just to get rid of the error that you were seeing earlier. So let me just organize my screen a little bit. So if I refresh, I'm still getting this error because for our change to be taken into consideration, we have to restart our backend. And if you are coming from the JavaScript world, you would be saying, this is going to be very annoying if I have to restart every time the project. And that's why I switch from Maven to Gradle. Maven is going to help us to auto-build the project every time there is a change. Maven does it as well, but it's very tied to IDEs. So Maven works with IDEs to be able to do that, and I don't want you guys to be having to work with one IDE, with one specific IDE. So Gradle is going to be IDE independent. So we would say Gradle we're gonna say build, and we're gonna say with the T, so it's gonna be continuous building. It's gonna watch for changes, and also we're gonna say don't run test every time there is a change. So, and by doing that, it's gonna watch our project file. So if I let's say change the controller from hello world to hello, let's say just hello. So if I refresh, so as you can see, it has rebuilt the project and our project has restarted. So if I refresh, we have simply hello. So here actually we're going to be having let's say have a request mapping. So we're going to be having things that are going to be related to our API version 1, and we're going to call it authentication like this. And the first URL that's going to be in our authentication is going to be a URL that's called user. So this is a URL that's going to give us back the authenticated user later on. For now, we're just going to send a user string, let's say. Let me change this to get user. And also, I have actually said it, but I didn't do it. We would be having a features folder that's gonna contain all the features in our project. So the authentication is a feature, the feed is gonna be a feature, and the profile is gonna be a feature. So that's how we're gonna be structuring our project. So authentication, and the controller should be in the authentication here. And let me delete this one, like so. Sorry, we would have controller here. Let's say controller, and like this. So the first thing that we are going to be doing is that we want to send an actual user that's coming from a database. So and how we will be doing that, we will be using a Spring Data GPA. So let's say Spring Data GPA. So Spring Data GPA is a package that's built by the Spring Boot team, and it's actually gonna help us map Java classes to database entities. It is also going to handle connections to databases, and it's going to be including all the drivers that are needed. So it makes working with databases very easy in a Spring Boot project. So first thing first, we are going to be needing the Spring Data GPA. So we need to install it from Maven. So let me go to the Maven repository, and the Maven repository is going to help us grab the thing that is suited for our build tool. So if we were using Maven, we'd grab this one, but we're using Gradle with the Kotlin syntax. So we'll grab this thing and come back to our project, and that's what we have so far in our Gradle.build. So that's everything that's coming from the Spring initializer. So let me paste, and let me actually separate things. These are going to be the things that will be helping us build the project. This is going to be our dev tool, and this is going to be things that are related to our test. So they are going to be grouped together. So also I'm going to remove the version, because we have this plugin for Spring dependency management. So this thing is going to use the right Spring package in terms of version depending on your Spring Boot version here. So that's going to be very handy for us. After adding our Data GPA dependency, we need to tell the library what class it should use to create the mapping to the database. So for that, let me actually create a package that's going to be called, not here, in the controller, and we're going to call it model. like this. And we are going to create a class that's gonna be called authentication user, authentication user, like so. So for now, our class, let's say, is gonna have a private attribute that's gonna be a long ID, like this. We're gonna be having also email, and let's say a password, like this. And we are gonna generate a constructor, let's say generate. So the first one, we're going to generate a constructor for all the trees, like so. And also we're going to generate getters and setters. So let's say getters for the tree, and also generate setters, like so, for the tree, like this. And also we'll be having a class that's gonna be containing a constructor that's gonna be empty. And this is important because for us to be able to send this user object as a JSON to our client, we need to convert this to a JSON, and that is going to be done with the help of the Jackson library. And the Jackson library needs this empty constructor to work. Our Spring Data GPA doesn't know about this class, so we need to tell it to use this class to create SQL table. So for that, we're going to use the entity annotation, and we're going to say it's going to be at entity, like this. And we're going to say create a table that's going to be called users. So let's say entity. It should be coming from the Jakarta persistence library, and I don't know why it's not working. So let me check. Yeah, sorry, actually guys, we should be using the Spring Boot Data GPA, not the Spring just the Spring framework, because the Spring Boot is actually gonna using this one is gonna make us do some setup work, and the Spring Boot is gonna take it to the next level, simplifying things a little bit more. So that's what we are gonna be doing. So let me come back here and search for Spring Boot Data GPA, like this. Let's say Maven. So this is the one that we need. Let me come here and grab this, like this. And as you can see, they are slightly different. This one is a starter that is done by a Spring Boot. So a Spring Boot actually create starter packages. A starter package is a package that contains a lot of different other packages, and that's going to help you set up specific things in your project very quickly. So if we had to use Data GPA using this one, we would have to install the Jakarta library ourselves, and that we don't want to do. So let me just do that and install my packages. Now hopefully if I come back here to the entity, so we have the Jakarta persistent, as you can see. And for this to work, we are gonna add the ID attribute. So we already have an ID attribute, but it doesn't know. So we need to add the ID like annotation, like here at the top. So it would have generated the get ID, another get ID, but we already have one, so we're gonna remove this. So it should be name. Sorry. So yeah, now this is going to create a SQL table, but our Spring Data GPA doesn't know how to connect to a database so far, and we don't have a database. That's where Docker is gonna come into risks, because we don't want to create a database on our machine and connect to it in all. We want to be able to give the project to our colleagues and they are able to run it like very quickly. So for that we're going to be using Docker. Let me just create a Docker file. It's going to be called Docker Compose .yaml, and make sure you install Docker on your machine and that it's running. So I already have, and so we need, and then we are going to just, I'm going to copy paste, as it's not a Docker video, so we just have to specify the version and we specify the services that we need. So our image is going to be a MySQL. So this image is going to be coming from the Docker hub, like Maven, but for Docker, where you would have a lot of images that are built by others that you can use. So for example, if I've already visited MySQL here, so I can grab one of these. I actually have chosen the just latest, and I'm not specifying anymore anything, so that will work for me. And I'm saying that the MySQL that's gonna be running in the container is gonna have a database called LinkedIn, and the root password is gonna be simply root, and we are mapping the port that's running within the container with the port on our machine. So that's it, and then we need to run this thing. So we're gonna call Docker compose up like this. As we are running for the first time, it may be gonna take some time, but it's now working. So we have a SQL database that's running, but so far our Spring Data GPA doesn't know how to connect, so we need to tell the package using our application.properties. So here, sorry about that. So here we're gonna add some variables. The first one is gonna be the URL to our database. So as I have showed you earlier, our database is going to be running on 3306. So that's what we are adding here. And then we are saying the database is going to be called LinkedIn and created if it doesn't exist, where we should specify also the database username and the database password. So the password is root for the root, and so the user we are using root here. Then we have added this one to say that every time the project restart, I want you to delete the existing database and create it so that it matches our entities that are these classes. So if I come back here and restart the project, I believe it has, so we have an error. What is the error? So yeah, we are getting this error because Spring Boot Data GPA, upon starting the project, is trying to connect to a database, but it doesn't know which one, because Spring Data GPA is database agnostic, so it can work with all the databases that are out there. And so you as the developer have to tell it like which database it should pick. So for us, it's going to be a MySQL, so we need to add a MySQL driver. So we need to go to the MVN repository and grab it. So we're gonna be using this one, MySQL connector Java, and it's gonna be the version. This one I have grabbed the latest one on Maven repository. So now, if I restart the project, hopefully it's going to work. So yeah, now it's actually connected. And if we connect to the database using a client, I'm using MySQL Workbench, it can be any client, so let's connect. So it's going to be on localhost, it's going to be on the port, because remember, we in our Docker, we said that the port that's going to be within the container is going to be mapped to the port on our machine. So make sure it's this one. And then we need to specify the root password. We said that it should be root as well in our here Docker file. Then we used to need a name for the connection, and we can say okay. So if I open it, as you can see, we have our database that's called LinkedIn, and for now we have one table, so it's going to be user. And if I click on it, we don't have anything, but we have the attributes that we have added on our authentication user class. So it has created automatically, it has taken this Java class and it's running SQL queries behind the scene and creating this table for us. We don't have a way to query the database in our code here. So for that, we are going to create a repository in the authentication folder. So we're going to say repository like this, and it's going to contain one Java class. It's going to be an interface. We're going to call it authentication user repository like this. And this is going to extend the GPA repository. So the GPA repository is coming from Spring Data GPA, and and we should tell what this interface is going to help us query, like which table, and since we are in our Java, which entity, which class, and our class is going to be the authentication user that we have created earlier. So that's it actually so far. And by doing that, we are going to be having methods that are going to help us query, and just to show you, I'm going to show you in a bit. So for now, that's all we need. And let us create a configuration class that's going to run upon starting the project, that's going to create automatically one user into the database. So let me create a let's say a package. We're going to call it configuration. We're going to call it load database configuration like this. And this load database configuration is going to be a configuration class. So it is going to let's say have a bean that's going to be a public command line runner, because this is gonna run like using the command liner coming from the Spring Boot, like running a command in the console or in the terminal. So let's say it's gonna be we're gonna call it we're gonna call it init database like this, and it's going to grab the authentication user repository like this. And we are going to say so we're going to create an authentication user. So let's say authentication user like this, one authentication like this, and we're going to give so let's say the email address. We're going to say yusuf@example.com. So let me just to make sure that I'm giving the right. So the first one is the ID. Let's say it's going to be, and we're going to change it in a bit. The ID should be like coming from the database. We shouldn't be setting this ourselves. But for now, let me also add a password. So let's say Yusuf. So I should actually switch these two because I want it to be in this order. So it is actually a number, I forgot. Let's say 1. Yeah, okay. So we created our user, and we need to save it into our database using this thing and add. So now, having this, upon restarting, is going to run this thing before the project run. So if I query, as you can see, now we have one user that's here. So earlier I said that the ID, we shouldn't be setting it ourselves, and it should be coming from the database. How we can do that? So for that, we just have to go here on the authentication user and say that this ID is going to be auto-generated. So we're gonna say it's a generated value, and we need to specify the strategy. So we would use generation type, and it's gonna be identity, like this. So by doing that, it's gonna generate it. The database is gonna handle the generation, and it's gonna increment this ID every time a new user is created. So for that, we don't need to pass it to our constructor here. So I'm gonna remove it. Let's come back here, up here as well. Remove this. So now, if we come back and query, as you can see, it's working. And if I create another one, let's say authentication user, and let me actually call it authentication user 2, and let's say it's let's call it Arnold. It's gonna be also Arnold, like this. Save it in user authentication repository .save authentication 2. So if we do that, so let me actually save it after. So if we do that and check our database again, as you can see, Arnold is going to be the ID number 1, and Yusuf is going to be the ID number 2 in the order of saving. So I have saved. Why it's registering Yusuf as number 2? This is weird, right? We're saving Yusuf first, and then, so let me actually comment this and check again. So Yusuf is number 1. So yeah, now it's working. So that's how we would create a user. So let me delete this one. 1 is enough for us for now. So remember, in our authentication controller, we have this URL that's sending a user, and we need to send the actual user that's in our database. And for that, we could access the user repository directly here, but for a cleaner project, we are gonna hide away the database from the controller. For that, we're gonna create a services folder. So we're gonna call that service, like this. Sorry, I intended to create a package. So let's say a package. I'm gonna call it service, like this. Create a Java class, and we're gonna call it authentication service, like so. Like this. So it's gonna be a service, like this, and we are going to, for now, add one so we are gonna actually grab the users repository. So it's authentication user repository, yeah, this one. And so we are gonna, let's say it's gonna be a final one, like so. And this is gonna actually auto wire for us. So we're gonna have a public class that's gonna return authentication user. How did I call it? Let me just check this. I've called it just get user. So we're gonna have an authentication user, let's say get user, and for now it doesn't take anything. Later we're going to change it, and it's going to use the authentication repository dot find. So for now, let's say find one, and or else we're gonna say throw. We're gonna say we're gonna throw a legal argument, actually legal argument exception, and we're gonna say user sorry, not found. Let me actually grab the email and say a string. I'm gonna get the email here. So we're gonna say find by email. Add it here, like so. And as you can see, we have a lot of common query functions like find by, find one, that is gonna be common to everyone. But when you need something that's specific, like not every project is going to have an entity that's gonna have a user attribute. So if it's specific, you need to create it. So we need something called find by email, like this. So for that, we're gonna go to the authentication repository here and say, we're gonna say here like this. We're gonna use IntelliJ is auto-completing for me, which is cool. So find by email. So the find by is something that's common, like anyone can create this, and then here you should use the same thing as a attribute that is in your model. So if we say something like find by foo, for example, this is not going to work because it doesn't know about foo. So you should use a correct attribute here. So that's all. And then if we come back to our where were I? So in our service here. So now it is working, but something is wrong with my syntax here. So yeah, I actually intended to use or else throw. So now it's working. So user not found, like this. And we're gonna be using this one in our controller here. So we are gonna use a private final, like this. Use the class and say this, like this. And here we're gonna say get user, and we're gonna give him for now something that's gonna be like hard-coded. Sorry, where were I? I was in the controller here. So yeah. So later on, this is gonna come from the authentication context. So you'd use a dynamic email to get the authenticated user. For now it's okay. So just we need to change the return type of our function. Instead of a string, it should be user authentication user. So if I save, and now if I come back to the browser on our localhost, and yeah, so here we wouldn't have anything because I removed that. So now if we go to API, we say a version 1/user like this. So something is wrong. Yeah, I forgot authentication, so it should be authentication user. So as you can see, we are getting the user back. It is a JSON actually response. So let me come back here. So network, refresh all. So as you can see, if we look at the preview, as you can see, it's a JSON, and if we look at the headers, the response header is also a JSON. So all of this, Spring Boot is figuring it out by itself. Like, all we have to do is to tell him the type of the content that it's returning, and it's going to set the right headers. And to be able to convert this Java class into into this JSON format, it is using a library that's called Jackson, that is included by Spring Web, like not by Spring Web, but by the Spring Boot starter web. So this one includes a library called Jackson. So you can actually see it here. If I open the external libraries, and let's search for it's called this one. So this thing is doing the transformation of Java classes to JSONs. So that's working, which is good, but we have a problem. If you have taken a security 101 course, you know that we shouldn't store passwords like this. And if your company is operating, for example, in Europe, and you store passwords like this one, authorities are gonna come after you, and you're gonna pay a lot of money. So this is not good. We should actually hash the passwords before saving into the database, because a database, actually a lot of people are going to be having access to it. For example, in a team, there are going to be database engineers or data analysis engineers. They are going to be using the data to do a lot of things, and they shouldn't have access to the passwords of users. So we should encode them. How we do that? So let me come back here, and we are going to be having a class that's gonna help us do encoding. So in the authentication build folder, I'm gonna create a package that's gonna call utils. We'll be having utility components here, and let me create a Java class. I'm gonna call it encoder, like so. So the encoder is gonna be a Spring component, like so. And what it contains is going to contain two functions. The first one is going to return. So we're gonna call it encode. So it's gonna take a non-hashed password. We're gonna call it like string raw. Let's say raw string, because we're actually gonna be using this encoder class to do also like encoding tokens later on, the token that we send by email. So let's say, and it's going to encode it. But so how it's going to encode it? We will be using actually the message digit from the Java security class. So this one, and we're gonna call it digest, and we're gonna say, so digest going to be a new digest. No, that's not what I wanted to do. So we're gonna say get instance of the SHA 2056. So it shouldn't be new, like this, like so. And what actually we do, something is wrong, I don't know. So actually let me add this thing in a try catch. We're gonna say more, yeah, like so. We're gonna say error encoding string, and we'll do like this. And what an encoding does is that actually it will take a string and create an encoded version, a hashed version of it. And we would assume that it's not possible to come back from the hashed version to the initial version. So if someone takes the hashed version from the database, he cannot do anything with it. And then when we receive the password from the user in the form, we're gonna hash it and compare the hashed versions. So that's what we will be doing here. So we're gonna say return a base 64. Sorry, a base 64 from Java etil, and let's say get encoder, and we're gonna say get encoder. We're gonna call encode to string, and we're going to give it the our raw password and get its bytes, like so. So that's it. Actually, that's what we will be doing to encode our and then we're gonna have a match function as well, and I'm gonna paste it. So let me say it's gonna also use a string. So we're gonna say raw string, encoded string, so what we're saying that we're grabbing the raw string, encoding it, and then saying it should equal the encoded one. So that's what we will be using. And let's come back to our load database here, and we're gonna grab the encoder, grab final encoder like this, and we're going to create the constructor like so. And here, instead of saving Yusuf like this, we're going to use the encoder dot encode and give it the password, sorry, like so. So now it restarts the project, and let me come back here in the database. If I run again, so as you can see, the password is hashed, and if I refresh here as well, as you can see, we're getting a hashed version of our password. And then again, we don't need actually to send this password when a client requests for the user. He doesn't need to know about this password, even if it is encoded. So for that, we're gonna come back to our model here and say that the password should not be sent as part of the JSON. So we're gonna tell that to Jackson. So there is this JSON ignore that's coming from the Jackson library, and by adding this, it restarts. If I run again, as you can see, we're not getting the password here. So we are safe here, and also we are safe in the database because it's hashed. This seems a little bit weird though, right? It's actually let me come back in the code. Yeah, so I know what's happening. So we are not actually encoding really. This is just taking the string and converting into a base 64. So if I actually copy this thing and paste it in a base 64 encoder and then run the code, so we're getting back. So we didn't really hash the thing. So let me come back here, and we're gonna create a byte. So this is what we should be doing first. So we're gonna using the algorithm, the SHA algorithm, and we are saying, so digest this the string that you are getting here. So actually we don't need, yeah, we get the bytes, and we digested, so we hash it, and then this one we are gonna convert it into base 64 and store it. So let me come back here, like so. So now if I run again, so let me come back, run again. So as you can see, now we have a password that's very weird and it's hashed. So even if I come back and add it here, he's not going to figure out anything. So it's just getting a junk. Now let's actually go back to our controller and create an endpoint that's gonna help us create a database like with a request. So let me come back here to, let's say, our controller here, and I'm gonna add one endpoint. So let me actually just paste in the endpoint here. So it's gonna be a post mapping, and it's going to return a authentication response body. We don't have this class, we're gonna create it. And for now, actually, let me remove it, and I'm gonna add it later to explain what's happening here. So it's gonna be a request body of this type, and we don't have the authentication service. Yeah, it seems to be like this. And let me create this class. So this is a data transfer object, so I'm gonna create a DTO folder here, package, and I'm gonna call it DTO, like so. And this DTO is going to be quite simple. So I'm gonna create Java class called authentication response body. So here we're gonna import it, and also we need the authentication request body, so the data that we're gonna be getting from the user. So let's say it's going to be a Java class, and I'm gonna paste it as well, so like so. For now, let me actually remove this. I'm gonna make a point with this in a bit. Move this. So for now, as you can see, it's just a simple Java class. We have a email field and then a password field, and getters and setters. In the response body, we have also just a token. So that's going to be the authentication token that we're going to be setting it later on, and a message, and then some getters and some getters. So if I come back, why I'm getting this thing? Yeah, but no way. So if we come back here to the controller, sorry, yeah, here. So we need to import it as well, like so, and we need to create this register method. Create the register method. So let me come back to the authentication user. Yeah, authentication service here, and we are gonna create a register here. So we're gonna use the authentication repository, and we're gonna say save, and we're gonna create the authentication user, pass it the email and the password that are coming from the body here. So let me hit save. I don't know why I'm having this missing return. Yeah, that's the problem. So for now, and the register class is actually going to change a lot, because this is where we will be sending emails and all. So for now, let us keep it like this. Yeah, sorry, actually. So we are going to return a authentication response body here, and we are going to say, like in terms of message that the user, we're going to be sending a token for now, just as, let's say token, and here we're going to say user registered successfully, like so. So we need a new here. So now if I come back here, the controller should be working fine. So let me come back. In order for us to send data like in a post request, I'm going to be using Postman, and I have already created some endpoints. So I will be using the post register, and I'm going to be sending the email and the password. So let me send this and see what happens. So I'm getting this, it's saying that it has registered. So if I look back at the database here, we have two users who have the same email. That's bad, right? We shouldn't have the same email added to different users. So we need to fix that first thing first. So let me come back here in our entity here, and we're going to say that the email class is going to be a column that's unique. Let's say so we're gonna say, yeah, it should be, we're gonna say unique is going to be true, like this. And while we are at it, we also I think actually let me keep it like this for now. So upon restarting, the first one is gone, and then if now I send this, I'm gonna actually get back an error, an internal server error, because we are not handling errors so far. But let me just send another user, let's say Arnold, like so, and send. This time I'm gonna get registered. And if we look within the database, if I query, so as you can so I actually, it restarted. So let me send the user again, so like this, and then if I grab, this time as you can see we have two users, the one that is added by our load database by this class, and the one that we just registered. So if I send another one, let's say Anne, send, check, so as you can see we have Anne, which is with the ID 3. So but we're not encoding the passwords, which is bad. So let me come back here, and we're gonna say in the application, in the authentication service here, so it should encode this one. So we're gonna say encoder dot encode, and we're gonna pass it this one, and let me create this encoder private final encoder add it in the construction, like so. So now it should encode. It's going to restart. So if I check again, there's nothing. I call my postman, create Anne, send, Anne is created, grab, yeah, as you can see now it's hashed. A user, instead of sending, it sent like not a valid email. So let's say he just sends Anne like this. We actually are gonna be storing this data that's not correct, so we should stop this from happening. How? We would have to write some logic here and check that the email is a correct email using something like a pattern matcher or something like this. But we could also use the Spring Boot data validation starter. So let's say Spring Boot data validation starter Maven. I hope I'm writing things the right way. So this one. So we're gonna grab this, say oops, grab it. So this, I'm gonna add it. This is going to help us have data validation using annotations like we did so far. So I'm gonna name, and now if I go to my authentication user here, I'm gonna say that the email is going to be a email. So I'm gonna add an annotation called email like this. Yeah, now it's coming from the Jakarta validation that's added by the Spring Boot validation starter. So I'm importing it like so. And also we're gonna say that it should actually not be null. So, and also this one is going to be coming from the Jakarta validation. So now let's come back here and let's send an email that's not correct. So let's say send, and if we open, we're getting an error here, and the error is saying Jakarta validation constraint violation exception. So it's saying validation failed for class authentication user during persist time for a lot of things, but it's saying that the property email is not valid. So now it's working. And guys, in a bit we're gonna have a better error handling. This is like not a production grade errors. So this error checking is happening when we are about to persist the data. So after going through our controller, so our controller would go and then it's gonna call our service. Our service is going to be doing a lot of things. It's going to be sending emails and all, and then at the time where we are saving the entity, we're getting the error. So which is quite not good, because we need to detect that the data that we have received is not correct like earlier in the process. So that's what we will be doing. So if we go back to the authentication request body here, we can add some validation here. So we're gonna say here, we're gonna say not blank. This should not be blank, like so. And when it's blank, we're gonna send a message saying that email is mandatory. And also we're gonna do the same for the password. So we're gonna say not blank. We're gonna have as message password is mandatory, like this. So after adding this, and we could also actually have added the here the email here, so instead of there, but just to show you that we have different places where we can have this. So now let's say so we have added the @email on the model, and we have added the not blank on the controller, on the DTO. To show you that this one is also working, let me actually or that is not working still, let me send this. So now if we look, it has actually registered an email that's empty. So let me come back here and check. So it has registered an email that's empty. An empty string is not null. So so here, what we have here is not working, and what we did here, what we did on the DTO level, this should work, but it is not. Why? Because there is actually an extra thing to do to validate DTOs. The validation of the entity here is being done by Hibernate, by like the ORM that's behind data GPA to validate the constraints. But here there is nothing that tells on the controller side. So here we're going to say that this request body should be a valid one. So we're going to say valid from the Jakarta validation and save. Now let us let this run, and if I come here and try to send this time, as you can see, I'm getting an error that's not coming from our data GPA, but it's coming before. So we have a method argument not validation exception saying yeah, the email field is blank. So I think that it's very good to have the validation earlier on, so that your database doesn't have to do a lot of stuff. So earlier I was saying that we shouldn't be sending like errors like this, because our front end, the client that's using the API, and our front end team needs to understand things with like better error messages, not chunks like this. So we're gonna add error handling logic here. For that, we're going to create a controller folder on the I've already did actually here. So we're going to create a controller not in the authentication feature, but on the root, like project level. So because this is going to be applied to all the features of the project, so we're going to call it backend controller like this. And this one, all it's doing is going to catch all the errors that are going to happen in all the controllers of our project and format them. So for that, we need to add a controller advisor. So controller advice like this. So this is going to watch for all the controllers that are out there. Then here, let's say, let me add actually a very basic error handling here, just to show you. So we're gonna use an exception handler annotation like this, and we're saying we are handling any exception. So this is the most generic exception class that's in Java. And then we're gonna grab this from the Spring Web, and then also the status like this. Let me import the map class from Java util and save this one. Now if you come back here and try to send the same junk again, let's say, so as you can see, it has actually catched the error here, and it has formatted it very nicely, so saying that there is a message that's saying this thing. And we could also actually optimize it and say, just when it's an exception that we don't know, we're simply gonna say something went wrong. And for the exception that we know, like not generic exception like this one, we're gonna send proper ones. So for that, let me actually just copy paste the entire content of this class and save it, that we don't need this one, doesn't need them. So we have an exception for HTTP message not readable, and we're saying that that's actually thrown when someone sent a request to our post endpoint. For example, let's say it sent an empty, like here we're expecting for a body, our controller is expecting for a body. Let's say he sent an empty, things like this. So this, when this happens, this error is going to be thrown, the HTTP message not readable, and we're catching it. We are saying sending a message here. And also let's say I'm gonna come back. Let's say we send this like this. So when that happens, we are gonna be having method argument not valid exception class. So let me actually remove this, how I know about this exception. So I'm gonna remove this one, okay, and send the request again. Now it's actually being catched by the last one. For now, let's remove this one as well to show you how I know about these errors. So let me send. So if we look at the message, it's saying that there is this exception that has been thrown. So I just copy this one. Instead of letting the Spring error handler do this, I am catching it myself here. So it's the same, as you can see, the method. and it's coming from the Spring Framework web bind, and that's from where I'm importing. And I have others as well. In all of this, the process is the same. Every time there's an error, I check it and I try to create something for it. So that's gonna be our controller advice. And as you can see, we are sending the right status code every time. Like when it's a not resource found exception, we are sending a 404. And every time we try to send the right status to help our front-end team. And if something that we don't know, it's a generic exception, we're sending a 500 error. And here, normally we shouldn't send this one. We should send something like something went wrong, because we don't want to tell like the client things that are very backend related. For now we can keep it. So let us come back to our controller here, and I was saying that this user is actually should be coming from the authenticated user, and so far we don't have any authentication. All this route actually is not protected. So how we would protect this route? In a lot of Spring projects, the go-to way of adding security in a project is to using the Spring security package, but it's a very complex package. Sorry, I wanted to show you this tab. So it's a very complex, this is a very simple architecture of the Spring security, but it's way more complex than that. And often you would find yourself trying to understand the library rather than the concept that it's resolving. And I use it, don't get me wrong, I use it at work, and I use it in a lot of places, but I just think that it's interesting to create the authentication yourself, like building everything from scratch once upon a time, so that you understand better what the Spring security is doing. So that's why in this video we will not be using Spring security, and we'll be building our security logic by ourselves, and it's not gonna be that difficult, as you can see in a bit. So how we will go about doing this? First thing first, let us talk about security. Security is all about getting a request from a user and being able to validate the user. So the first thing to do is to help to allow the user to send you its email and its password. And then in the next request, so for example, if you log into your LinkedIn account, you're going to just be logging in once, and then you just continue using the website, because somehow they are able to know who are you, using something that's called token. And the very famous token that's used on the web is called JSON Web Token. So a JSON Web Token, let me actually go to gwt.io. So it's a way of ensuring user data. So it's something where you can encode a token and be able to say for sure that the token is not changed. So it can go on the web, and when you receive it, you are able to validate it, saying that it's not tampered, it's the right one. And in it, you can actually store some data like this, the expiration date, and also a name, anything that you want, a payload. So it's a hashing algorithm that allows you to embed data about a user in it, and you are able to know that it's not tampered. So that's what we will be doing. So we'll be adding a GWT authentication in our service, and to work with GWT in Java, we could write the hashing and the validating logic by ourselves, but it's gonna take a lot of time. So we'll be doing like everyone else. We'll be relying on a package that's called GWT API. So there are gonna be three packages. Let me add them here. So we have the GWT API in its implementation. So this says how it should. You could actually use others implementations as well. This is very common in the Java world. For example, a lot of things are, for example, the Java language itself, it's an API, and there are different implementations of it. Like we have all the things that are coming from OpenJDK and things that are developed by Oracle. All these use the Java API. So the blueprint of Java somewhat. And this is implementation of it. And this, as you can see, it contains a Jackson here, because this is going to help us serialize. So take the token and send it as part of a JSON. That's what's going to help us do so. So that's what we will be needing. And then here in the utils, I'm going to create a class that is going to be called JSON Web Token. So this is going to contain everything related to encoding and decoding and validating JSON Web Tokens. So let me actually paste this and explain what's in here, because actually let me come back here and reload my project so these are added. So now actually a JSON Web Token needs a secret, so it works with a secret. You like take some data about a user. So if I show you the generate token here, so us, instead of like adding in the token the name of the user, we will be storing its email. So that's going to be the subject, and we're going to say the creation date, the expiration date, because like any ID, a JSON Web Token should expire at some point. So that's what we are doing here. And then we need to sign this thing. So by doing that, we are sure that every time we receive a JSON Web Token, we know it's not tampered. So this is why we need a signature, and this signature should be a secret, something that nobody should know. So we are going to be storing in our application.properties. Let me grab it. This one. I am going to paste it here. So actually it cannot be any string here. It should be a specific type of string that you can use as secrets. You just need to like go on the internet and type like GWT secret generator, and there are a lot of them, and you can generate one. So I have pasted this one. Let me come back here. So when we are generating, so we sign it like this, and then for example, let's say we want to validate, we want to make sure that the token is not expired. For that, we're going to call the extract token expiration, and it is this function. This function is trying to get the expiration date from the claim, and if we look at the claim, it's calling the extract all claims. In the extract all claims, it's the one validating. So here, let me actually add it next to it here. So here, that's where we are generating, and that's where we are validating and then returning claims. Claims are just the data that is contained within our token. So here, we're saying that you need to parse the GWT that you are getting the token. You need to verify it with the same key, and then get the payload. So that's what we are doing, and that's it. And for the JSON Web Token, and this we will be using throughout the project, and it's in the util folder. When we will be generating this token upon receiving a login request, and we don't have a login request for now, so that's what we will be adding in our controller here. So let me actually grab it, because it's gonna be the same as the register. I'm gonna add it here at the top, and actually calling it authentication service like this. and we are going to be getting an authentication request like before, so an email and a password that should be valid, and we would call the login method. So let me come back here. Actually, we don't need here. So that's our login. What we are going to be doing in the login? First thing first, we are going to try and grab the user that is related to the login request that we had. So in the login request, we're getting the email. So we're gonna say find by email, and if not, throw an error. So that's the first thing to do. Then we have to check that the password that's in the request matches our the password that we have pasted in our database. For that, we're going to be using our encoder. So what we are doing here, we're saying encoder.match. This is the method that we have created earlier. We're grabbing what is within the login request body and within the user that we have grabbed. So if these two do not matches, we're going to throw an error saying that password is incorrect, and it's going to be cached by our backend controller and sent a nicely formatted error to our database. So if this is good, we have received an email that's valid, and also the password is valid. So now we're gonna create a token. So we're gonna say string token. We're gonna generate a JSON web token dot so we are going to generate a token like this, and we're gonna pass it the login email. We need it here, so let me actually generate the JSON web token, final JSON web token like this. Add it to the constructor. I don't know why this is, sorry, it should be coming from this, like so. So we would have generated a class. Now we just simply return it. So we're gonna say we're gonna use the authentication response. We're gonna send the token and say authentication succeeded. And in the upcoming request, every time the user needs something, he's gonna send this token to us, saying, hey, I need to access a resource and this is my ID. And since we have stored a secret here that nobody knows, with this we are able to tell that the token that we are receiving is generated only and only by us. So that's the handy thing about JSON web token. So let me come back to where was I? So I was in the authentication service here. So let us test all of this. So here in the repository, let's say controller here. So let us test this post request. So let me come back to Postman. I have already created this. So it's a post request that's going to be sending a JSON, and it should contain a user and a password. Let me try this. If I send, as you can see, I'm getting user not found, and this is fired here. It's this thing, this error, and it's catched by our backend controller, and we're getting this nicely formatted error. And that's happening because there is no user at LinkedIn in our database. Let us check it. So if I grab all the, so we only have this one. So we're gonna use this one to authenticate ourselves. So let me come back to a Postman and use this and send. Let's say send. We should get another error. So the error is saying that the password is incorrect, which is normal because for Yusuf, our password was Yusuf, like this. Send. Now we are getting our token back. So this is going to be stored by our front end by our client, and it's gonna send us to it. So actually this, you can check the content of this thing by pasting it here. So we have actually signed it using a base 64 encoded secret. So as you can see, we have added the email in the body, so anyone can actually read what's in the payload. So you shouldn't send sensitive data here. The idea is that to store only the thing that's gonna help you identify your user. We are able to identify a user by its email, so that's why we are signing it here. So everyone can see the data that's in the payload, but no one can authenticate this token, like can say for sure that this has not been tampered by someone. For example, let's say I'm gonna change this. So it's changing, it's generating another token. So I can use this one. But because we have a secret that's in our application.properties, that's gonna help us notice when anything changes in our token and reject it. We should be able to access private routes using this token, but we don't have any private route actually. So let me actually so I don't need any token, and let me send, and I'm getting back my user because it's not private. So let us create a filter that's gonna prevent anyone to access if he doesn't have a valid token. So actually, like as I said earlier, in a Java-based web application, we have a server which is often Tomcat. So that's something that's independent, that's going to be running, and that's going to be calling our classes. And from the time a request comes into the Tomcat and coming to our controller, which is these things, there are a lot of things that happens, and we can actually do a lot of things. So we can create something that's called a filter. So a filter is going to run before the request reaches our controller, and that's where we are going to handle private routes. So I'm going to create a folder. I'm going to call it filter. So let me create a Java class, and we're going to call it authentication filter. Authentication filter, like this. And this authentication filter is going to be a component. It's going to be a component. And since we're using a Spring Boot, we simply would need to add this component at the top. It's going to create a bean, and to be able to use it as a filter that's going to really run before the request reaches our controller, we should extend the HTTP folder. So extend the HTTP filter like this, and this HTTP filter should be coming from the servlet Jakarta, like so. And in here, let me actually just paste some things because we don't have to type it all. So here we will be having a list of unsecured passes. So there are passes where we didn't need a token for them to work. Like to log in, you're logging because you don't have a token. You register because you don't have a token. You send a password reset token because you have forgotten your password, and also the reset password. So this is where we send an email, as I showed you in the beginning of the video, and this is where we validate the token that has been received by email. So that's what we will be needing. Then we're going to be having two attributes. We need the JSON of token component because it's going to help us validate our token, and also we need the authentication service. Let me actually create the constructor so that these are auto-wired. We need the authentication service because we're gonna actually we're gonna try to check if the email is in the database, and then we need a a class, a function that's called, that has this signature. Let me paste it. So it's actually part of the HTTP filter. We can it's called do filter. Maybe I could find it to show you guys. So it's this thing, as you can see, and we are overriding this thing. So we need to, why is it's yelling? Yeah, okay, sorry, my bad. This should be outside of the, it should be here. So let me import this from the Jakarta servlet. So this one, the filter chain as well, IO exception from java.io, and the servlet exception from Jakarta, like so. And what we are going to be doing here, first thing first, since our front end is going to run on a different port, we need to set some like cross-origin request, like we're allowing our front end to request our backend from a different URL, so that we need these headers for this to work. This you're gonna be understanding when we will be building the front end site, but let us add them here. And then also we need to add this for the course to work, because the cross origin request, when the browser is about to send a request to an API from a front end that's different from the front end URL, it's first going to be sending an option request. It's like get, but it's called options, and it's going to check, hey server, can I get data from you? So for this to work, our server should say, it should respond with a status of okay. I actually have passed a lot of time trying to figure it out why these weren't working, and I had to add this one. So that should be there for the course to work. So far we're handling cross-origin related things, and we are not doing any authentication. So the first thing is that we're gonna grab the path that the user is requesting, and we're gonna check if it's part of the unsecured URLs. If it is the case, we don't do anything. So if it's part of the unsecured so we're gonna say the chain, so go ahead with the other filters and reach our controller, because it's a path that should not be secured. But when the path is secured, that's where the magic should happen. Here we're gonna have a try catch, a try block like this, in the catch exception, like so. So here what we do, we are so how the client is going to send us actually this the token. So it's going to be sending a barrier token. A barrier token, if you don't know, is a header. So header bearer, it's bearer, sorry, yeah. So it's a bearer token is, it's going to be sent as a like authorization header. So that's why we first need to grab the authorization here. So we're gonna grab the authorization header, and then we're gonna say if the authorization is null or that it doesn't start with barrier, we're gonna we're gonna say that the token is missing, and this is gonna also be catch here. So there's one thing that we should know actually, is that the error that are thrown in the filter are not catched by our backend controller here, because filter runs before our controllers. That's why we need an exception handling here. So we will be grabbing, and let's say we're gonna add a response here, set the status of unauthorized, so you are not authorized because your token is missing, and set the application type and send this message like so. Save, and then if this is okay, so we have a bearer token, we're gonna grab the like if I show you here, so the barrier token is like this, and we don't need the first 1 2 3 4 5 6 7 characters. We need everything that's after that. So that's what we're doing here. So we're grabbing that what's after, and then we are gonna call our JSON token, and we're gonna say, is this token expired? And the expired function, as I showed you earlier, is also gonna check that it's gonna check first that the token is not tampered and it's something that we have generated, and then it's gonna check for the time that it's not expired. So after that, we are going to grab the email from the token. Then we're going to use the authentication service and check that there is a so it should become from here, yeah, that there is a user that's related to the email that's in the valid token. And if it's not, this one is going to throw an exception, and that's going to also be catched here. So, and after that, we are going to set an attribute on the request. We're going to set an authenticated user on the request, and then call the do filter. So go ahead. Now, everything that's going to happen after our filter, like the controllers and also other filters, are going to receive a request that's going to have an authenticated user attribute that's going to be of type our user. And that's how we do. So that's it for our controller. Now, if I come back here and try to get the user, let's say get user. Now I'm getting this error. It's saying you cannot because you don't have a token, and this is the error that we're sending here, and we're getting a 401 unauthorized. So let me come back to the login. Let me log in again. I'm getting my token. I'm gonna grab it. So come here, add the barrier token. So choose the barrier token here and send. So now it's validating, and we are getting our the data back. So let us actually tamper this data. Let's just go here and on the GWT, sorry, on this, yeah, here, and let us tamper this data. Actually, let's say someone changes this thing. Let us just change the expiration date here from 8 to 9. Let's say just this change, and let us grab and try to get the data forward with this send. As you can see, it's not gonna pass. As soon as someone touches this thing, it's not gonna be a valid one anymore, and we're able to know that it's the right one. So far, when we have the right token, we are getting the user back, but it's not the user that's in the token. To show you that it's not the case, let us actually register a new user, another user. I'm gonna call it Anne at example.com, like so, and the password is going to be Anne. Send. Okay. So actually, for the registration, we didn't do we didn't add the token creation part, and we're gonna do it in a bit. For now, let us just log in since it's created. So I'm gonna use Anne here and say Anne, like so, and send. So I'm gonna send my token and say I need my data back, but I'm getting Yusuf because we, if you remember, hard-coded this thing. So let me come to my controller, authentication controller here. We are hard coding this thing. We need to grab the user that we have set it here actually. So that's what we will be doing. So here, let us come back to our controller here, and here we're gonna grab the user that's, so since, as I said, the filter is gonna be running before our controllers, at this point the user is either has been rejected because it didn't have a token, or this token was valid and we have the user in the request. So how we would grab this? We're gonna just to go and use the add request. It's request attribute like this, and our request attribute is is called, let me grab it from here, it's gonna be this thing, and this should be coming from the Spring notation, should be a string like so, and it's of type authentication user, and we're gonna be authentication user, and here we're gonna say that it should be authentication user dot get email like so. I'm gonna let it run again. Let us come back here. So register Anne again, and let me log in with Anne, grab its token, come here. Now I should receive Anne instead of Yusuf. So as you can see, we are getting Anne. So let us actually also generate the token upon registration. So like we did for login. So for registration, we generate the token simply after saving, like within the database. So here we're gonna say so after we're gonna generate a string. It's going to be our token, and it's going to be coming from JSON of token, and this time we're gonna be generating, so it should be JSON of token like this. We're gonna generate, yeah, like so. So we generate it and we give it here like so. Save. Now if I register a new user, so instead of Anne, let's say I register I'm gonna register Pooja and send. Now I'm gonna get back its token right away upon registration. So get user, send, yeah, it's Pooja. We are able to register a user, log in a user, get the connected user, but we are not able to verify its email. So we are just trusting anyone that sends us an email. We're saying that it's his email, but we should validate that by sending a token. So for that, we will be needing to send emails, and we are going to grab the Spring Boot starter mail, which is another Spring Boot starter that's going to include anything that you need to send emails. So save it and start, and in the field we're going to create a Java class that's going to be we're going to call it email service like this, and I'm going to actually paste its content as it's not very difficult. So why is yelling? Cannot auto-wire bean. Okay, I know what's happening. So for now, we'll just know that we are grabbing the Java mail sender. It's coming from the Java mail sender here, from the Spring Boot starter that we have added, and it's gonna instantiate it here. And then we have only one method. It's gonna receive an email, a subject, a content, and it's gonna create a like email using the mail sender, and then it's going to create a helper, and then here it's going to set the email from which the email is being sent. For us, it's gonna be no reply at LinkedIn, some bullshit. And then we are setting the subject, the content in so we are saying that it's HTML content, so it's not just a string, and then we are sending it. And upon creating this method, we are getting errors here, and also this. Why this is happening? So we are saying to Spring Boot, give me a Java mail sender bean. But for this to work, actually, it needs to know what is the SMTP server, like the server that's able to send email that I should be contacting. And that we didn't specify. That's actually why it's yelling. So we should specify our mail host. So the server that's going to be handling mails, so it's going to be running on localhost. We have to specify its port. We're going to specify the port like this. Then we are also going to say that to connect to the SMTP server, you don't need authentication. So we're going to say authentication to false. And yeah, so we do that, and we're still getting an error because we're saying you're going to be connecting to an email that's at localhost 1055, but it's not running. So when it tries to connect, it's failing. So that's where we will be using Mailhog. So I have talked about it earlier in the video. So Mailhog is actually an SMTP server. So the web and API based SMTP testing. So it will allows you to emulate a email service. So, and the handy thing about this is that it's going to also like if you try to send an email from it, it's also gonna receive it. So you don't have to send real emails to people. And we will be using its Docker image. So Mailhog Docker. It should be Mailhog. And so yeah, it's this image that we will be using. So let me actually just paste the configuration in our Docker Compose here, like so. So we're grabbing the Mailhog image, and we're saying that this server port is going to be matched to a port on our machine. And also the handy thing about Mailhog is that it's going to give you a right off the box UI for also testing visually. So now if I run again, yeah, it should still be failing normally. So let me come back to my, so if actually someone tries to access this thing, it's gonna fail. Yeah, to show you, actually I'm gonna inject this email service and our authentication service here. Let me come back. So here we're gonna include private final add it to our controller, and let's say upon registering the user, we're gonna say email service that send email to the user. So it's gonna be a request body.get email. The content is gonna be the subject is gonna be just something, let's say some subject, and the body is going to be some body like this. White selling. So we need to actually let me add the exception here and hit save. So everything seems to be working, but we are actually gonna get an error when we register the user. So now if we try to register here, let's say register Pooja here, send. So that's weird, it shouldn't be working. let me check. So we are sending this and we don't have a SMTP server, so this should actually, yeah, here. Okay, so we have a problem here because since we have this problem, this didn't restart it, so the project is actually not updated. That's why we were able to register this user. So we need to fix this. So now this is running. So yeah, this has restarted. If we send this, so we are getting a mail server connection failed. That's what I wanted to show you guys. So that's because we have added on our Docker Compose, but we didn't restart it. So there is no server running for now. So let me stop this and run a Docker Compose again. Hopefully it's gonna pick up. Yeah, it has detected the mail hog. Now it's running. So now if I come back and send this time, okay, the database is already there, the mail. Let's send them junk. Now we're getting back and it should have sent an email. So as you can see, our mail hog has received an email from, let's say, at example.com. So as you can see, it's receiving an email, a sent email request to this thing. And if we access our web UI, it's going to be on localhost like this. We have received our email, so it's going to be some subject. So that's how we would handle email sending logic. And we have created this email sending service because we want to be able to send reset password tokens as well as email verification tokens. So that's what we will be doing next. But the first thing to do is to change our model. So on our model here, we should be able to add a like email verification token, as well a password reset token, and also an email verification token expiration date, as well as a password reset token expiration date. So let me actually just paste the complete authentication user. So we're going to be having our ID, the email, and the password like before, but then we'd have an email verification. Is email verified? It's going to be false by default. An email expiration token and an email expiration expiry date. Then we also would have a password reset token and a password expiry date like this. And then let us come back to our authentication service. So I'm gonna complete this one as well. So let me grab it here. This is the complete one. So what's happening here? So we have I have added actually this function that's going to generate a 5-digit number. So generate email verification token is going to generate 5-digit number, and it's going to return it. For example, the send and I also created a send email verification token function. This, what it does is that it's going to receive an email, it's going to grab the user, okay, that's attached to the email, and then it check that the user exists and that its email is not already verified. If it's already verified, it's gonna throw this error: email verification token failed, or email is already verified. If it's not the case, it's going to generate an email token using this function. It's gonna be a 5-digit number. Then we don't want to save this email verification token without hashing it, because this is a sensitive data. Like someone that has access to the database could use this token to do malicious things, and we don't want that. So we hash it. So here we're hashing it, and we are storing the hashed version on the user model, then we are going to create we're going to set the verification token expiry date using the local time from Java, and we're going to use some minutes from here. For now I'm just setting 1 minute, but it could be, so very often it's just 15 minutes or 30 minutes or something. So we're creating that, and then we're saving in our database. Then we're going to send the email. So the subject is going to be email verification, the body, and we're saying only one step to take full advantage of LinkedIn, enter this, and then we're sending the token and the duration, and then we call our send email service, giving it all of this and send it. And then we would have a validate token class function as well. This one is going to be called when the user enter its token in the UI, like I showed in the beginning of the video. So when that happens, we are going also to grab the user, and then we are going to check that the user exists, and that the encoded version of the token that we are receiving is the same as the one that we have stored in our database, and that the email verification token has not expired. If that's the case, we're going to set the email verification to true, that is verified, and remove all the tokens and save the user. Else we're going to say email verification token has expired, like we're checking that the user exists, that it matches, but the time has passed. So in that case we're saying this, and otherwise we just throw a generic request here. And these functions are being used by the register, and also so the first function that's using them is the register method. So that's what we did earlier. So we create and save the user, and then we are going to generate a token here. We hash it, we set the email token here, and also set the expiration date, and then save the user. Then we send the email and with the expiration date. So here we are doing upon register, but we also have this function, like this function, because we want to able to give the user the opportunity to ask us a new token if he didn't have the time. That's what I have showed you in the front-end UI earlier, that we will be building in the upcoming video. So we are sending the email, and then we are generating the token like before in sending it. And we have the send reset token is the same as the send this one. So it's the same as send email verification token. We do the same thing, and then we have the reset password. It's also kind of the same. We just validate the token, and if the token is valid, we use a new password and set it. So that's it of our service, and these are going to be used by our controller. So let me also complete the controller here, like so. So we have our two endpoints, the three ones, and then we have a validate email token where we would receive, it's a put request where we would receive the token, and for a user to be able to validate its email, he should be actually logged in. That's why we are relying on this authenticated user. But for sending, also it's the same for this, for sending email verification token, but for requesting a password reset token, we are not relying on an authenticated user, but we are receiving the request from the param, the email. So we would say on the UI, give me the email and I'm going to send you the token. That's what we do. And then after pasting the token on the UI is going to send a put request to this URL, and it's going to give us, as part of the request params, the new password, the token, and also the email. And then we would call our reset password like this. Now if I save all of this and we come back to our postman, so let us register a user, send. So the user has been registered, and if we go back to our SMTP and refresh, as you can see, we are receiving this token that will expire in 1 minute. And if we look in the database here, request like this, as you can see, Yusuf is generated like in the configuration class, so it doesn't have things like Puja. But for Puja, upon creating, we're sending a verification token email for the email, and also we have stored the hashed version of the token, and then sending him the plain code here. So now, and also, as you can see here, here we have email verified. It's 0 for like false and 1 for true. This is a MySQL thing. So let me come back here and try to verify the email. So for that, I'm gonna send the token that I have received with the token, with the authentication token, like this. So verify email, send. Email verified, token has expired because it was used for 1 minute. So now I should be able to ask for a new token. So let's say send email verification token here, and for here I also need to paste my authentication token and send. So it's saying it's sent. Let's come back here. So we have received a few seconds ago. Grab it. And now if we go back here, verify email, paste it, send, email verified successfully. If you look within the database, before it was 0, now if I refresh, so it's 1, and we have removed all things related to email verification. And it's the same logic for the password reset. So as you can see, we have built a complete authentication system that's working quite good. We have everything that an authentication needs. And now let us actually commit all of this. So git add, we're gonna say, let me change my username first. User.email should be my email, like this. Then we're gonna say git commit. We're gonna be using semantic commits messages, as I said. So implements backend authentication. Let me change it. Actually, it should be implement, not implements. And amend, like this. Clear the status, and we're gonna push it. So now if we go back to our GitHub project and hit refresh, as you can see, our backend has been pushed. So if we look at the commit, it's a very big one, as you can see. Hopefully we don't have to submit it to a human for a code review, because he would have been pissed off. So that's it for this video, guys. In the next one, we will be building, so the front end that's going to be using the backend that we have just built, and it's this one, as I have showed you in the beginning of the video, a front end that's also very complete and has all things that are needed, using a very professional UI that's built with React. So let me log in actually with the Yusuf at example.com. That's our default. So it's saying user not found. Why? Let me come back. What was the user that we have created? It's user, is what Yusuf. So it's user. Like this. Sign in. And the password was user, I guess. Yeah. So is working and we're getting our email here. So actually this user has been created and we don't have a token. That's an occasion for me to send you that the send again should work here. So we're getting code was successful. Refresh, we get it, grab, paste, validate, and we are on the home page. So that's what we will be doing in the next one. And if the video was helpful to you, please let me know in the comment section. Also feel free to share it with your friends who are also maybe interested in these topics, and like it and subscribe for the upcoming ones. Thank you so much and see you soon.